Hello everybody, I have 3 quick examples to show you. So the first one comes from class. A student was trying to solve this system of equations to figure out how many points of intersection between this parabola and this, it looks like, ellipse. So it seems like the most sensible thing to do here would be to substitute x squared directly in for y. Before we do that though, let's get rid of the denominators here by multiplying everything through by 4. So if I do that, this multiplied by 4 is x squared. This multiplied by 4 will be 2y. And then this multiplied by 4 will be 4. And so now I can substitute this in for y, and I've got this. So actually let's just do one more step. I was going to say looking ahead, but let's go ahead and expand this piece. So I've got x squared 2 times, okay, so what is this when I expand it? X squared times itself is x to the 4th, and I've got minus 2x squared and minus another 2x squared gives me negative 4x squared, and then plus 4 equals 4. So at the end of this process, I've got x squared 2x to the 4th minus 8x squared plus 8 equals 4, and let's collect all the terms, starting with the largest degree for x. 2x to the 4th minus 7x squared. So let's see, I've covered that. X squared minus 8x squared is minus 7x squared, and then plus 4 equals 0. So I've covered those. Okay, what are we going to do here? I wanted to remind you that an easy thing you can do here is to realize that all of the exponents here are even. So we could define a new variable p equal to x squared. Now I've got 2p squared minus 7p plus 4 equals 0. And so now you can solve for p by completing the square using the quadratic formula. Once you have two things that p are equal to, realize that x squared is equal to those two things. You take the square root, and x is plus or minus the square root of those two values of p. All right, so you'll need that in today's problem set. Let's look at example number 2. So this was the one that we thought so hard about in class. This is a parabola. This is an ellipse. They have no intersection points. So another way of saying that is that this system should have no real valued solutions. But we had a devil of a time trying to figure out how to actually prove that that was the case. What we did in class was we made this substitution. So we've got 2x plus 3 squared, and then this was x to the 4th plus 1, equals 1. And we expanded this, so this was 2x squared, 6x, 9. Let me get to the place where we were. So 2x squared plus 12x. This is 18 minus 1 is 17. And then x to the 4th equals 0. Okay, so will the same trick as example 1 here work? I could define p equals x squared, but the problem is here we'd have p squared, here we'd have p, but then this one would be square root p, and that doesn't really help us. Or, I mean, you could fiddle with it, but I don't think it really helps us. So people tried various things. Here's the thing I eventually came up with. What was it? I actually stopped at this point, and I said, all right, 2x plus 3 squared equals 1 minus x to the 4th. Okay, so now I have a sort of a case-based argument. Notice that the left-hand side here is always positive because no matter what x is, we're squaring it, which would make the value positive, and then multiply it by 2. So this is always positive. All right, so if the thing on the left is supposed to be equal to the thing on the right, that means the thing on the right also has to be positive. Or rather, a value of x that solves this equation would make the right-hand side positive. Okay, so we'll ask ourselves, when could this possibly be positive? Well, I know that x to the 4th can't be larger than 1, because if it's larger than 1, I'd have 1 minus something larger than 1. So this is only positive in the interval x is between -1 and 1. So far I've showed that if this has a solution, the solution has to be inside this interval. Because if it's outside this interval, you have a positive number on one side and a negative number on the other side, and so the two sides can't be equal. Therefore, x can't satisfy the equation. Okay, but I haven't shown that there are no solutions because there actually might be a value of x inside this interval that makes both sides equal. So step 2 of the argument is let's actually look at the size of the values on the left and the right. Well, here, so let's say case 1, absolute value x larger than 1. In that case, 2x plus 3 squared is positive, but 1 minus x to the 4th is negative. Therefore, x can't satisfy the equation. Okay, so that's my restatement of what I've said so far. Let's look at case 2. Case 2 is going to be x is inside the interval, so the magnitude of x is less than or equal to 1, which is just the same as saying that x is between -1 and 1. So here's my argument. Let's look at how big and how small this could possibly be. So because this is a parabola whose vertex has an x value of -3, we know that in the interval from -1 to 1, the y values are always increasing. So a different way of putting that is, like, let's imagine this parabola here. So between -1 and 1, we see that the y values are only increasing. So what are the y values in that interval? Well, let's write it this way. So when x equals -1, let's plug it in and evaluate. So we'll have 2 times 3 minus 1 is 2 squared is 4. So 2 times 4 is 8. So here we've got a y value of 8. And then here we've got a y value of 2 times 4 squared. So 4 squared is 16 times 2 is 32. So what we know is that 2 times x plus 3 squared is between 8 and 32 when x is in that interval. Okay, well, what about the other side? What we know about the other side is that the magnitude of x to the 4th has to be smaller than 1 because x is smaller than 1. And if you have something that's smaller than 1 times itself a bunch of times, it's only going to get smaller. All right, so therefore, 1 minus x to the 4th is going to be also smaller than 1. It'll be positive, but it's smaller than 1. So because the magnitude on this side is less than 1, and the magnitude on this side, the smallest thing it could possibly be is 8, we know that the two sides can't be equal, therefore there is no solution. Okay, so what I've written here is the left-hand side is strictly greater than the right-hand side, again, when x is in this interval. Therefore, the two sides can't be equal, and x doesn't satisfy the equation. However, between case 1 and case 2, we're covering all real values for x. Therefore, we've shown that no value of x satisfies the equation. Therefore, the system has no solutions. So that was my answer. There may still be a more straightforward way of showing this result, but I think this is actually pretty clean. So one of the homework questions is going to ask you to try and come up with a similar argument to this one for a new problem. As the last example, this was actually on the study guide for the quiz. I don't think I asked a question like this on the quiz. Anyway, let's do it. So here I've got an ellipse. Well, assuming that p doesn't equal q, it will be an ellipse. What p-value will make the ellipse have a height of 10? Nope. What q-value will make the ellipse have a height of 10? Because remember, this is the scale factor on y. So if you sort of don't remember anything about anything, you can always solve questions like this by plugging in things you know, solving for things you don't know. So what I'm sort of imagining here is I've got an ellipse that's centered at 3, -2. I wish that it had a height of 10. So what I'm going to do is I'm going to plug in the x value that I know. I'm going to plug in an x value of 3, and I'm going to solve for where are the two y values when x equals 3. And then I know that I want the difference between those y values to be equal to 10. So let's do it. Let's plug in x equals 3 to this equation. That gives me p 3 minus 3 squared, so that whole term drops out. And then I'll have q y plus 2 squared equals 1. So now I can solve for what is the y value when x equals 3. We are expecting to end up with 2 different y values here, so let's watch it happen. We've got y plus 2 squared, 1 over q. Let's take the square root of both sides. So y plus 2 equals plus or minus root 1 over q. And then let's subtract 2 from both sides. So we've got negative 2 plus or minus root 1 over q. All right, so what has this told us? Here is negative 2. So negative 2 plus a value is going to take us to this y value. Negative 2 minus a value is going to take us down here. So here we've got negative 2 plus 1 over q. Here we've got negative 2 minus 1 over q. What's the distance between these? Let's do the top one minus the bottom one to get the distance between them. So negative 2 plus 1 over q minus negative 2 minus 1 over q. And that's the distance. And what do I want the distance to be? I want it to be 10. Let's simplify. So negative 2, and then this is plus 2, so those end up adding to be 0. Here I've got root minus the opposite of the root, so that gives us 2 times the root. So 2 root 1 over q equals 10. Let's keep solving. So I've got, this is now 5, because I divided both sides by 2. Let's square both sides. 1 over q equals 25. And so that gives me that q equals 1 over 25. So now I have solved for the value of q that makes the thing do what I want. Okay, so on the homework, you're not going to be solving a question exactly like this, but what I want you to take away here is the idea that you should think about what value do you want to plug in that will let you figure out the thing you want to know. And then once you've figured out what you want to know, you might need to set up one more equation describing what you want. Like, for example, the distance between these two things needs to be 10. So rather than trying to memorize, I'm going to plug something in somewhere, ask yourself the question, what do I want to know? And that will tell you what you have to plug in. If I want to know these y values, I'll plug in x equals 3. If I wanted to know this y value over here, I could plug in something else. If I wanted to know where these 2 roots are, I'd have to plug in something else. So that's the exercise. Don't try and memorize some steps. Instead, think about what you want, and then think about what will get you there. Okay, good luck.